Hello everyone, welcome back to Tech Visits. And today we will create a simple smart contract which will enable us to vote for any candidate and see the results after voting for each candidate. So before diving into the code, there are few terms that we must know. So let's have a look at those terms first. So first of all, we will see what is a smart contract, what is EVM or Ethereum Virtual Machine, what is a gas and why is it needed, and few terminologies related to gas like gas price, gas used, total gas and gas limit. So let's see what a smart contract is. A smart contract is a computer protocol that facilitates the transfer of digital assets between parties under the agreed upon terms. It is not limited to cryptocurrency. A smart contract can be used to develop decentralized application. So let us try to understand it better by looking at an example. So as you can see in this image, if Alice wants to sell her house to Bob, she needs to rely for that to some third party like lawyers, brokers and insurance, and for that she need to pay some amount to them so that they can validate that transaction. But what happens if we try to perform this task in an Ethereum blockchain? So here we don't need any third party like lawyers, brokers or insurance, since all of that transaction will be validated by all the miners present in the network, and Alice just need to pay some ether to them as a reward. Now let's see what is an Ethereum virtual machine. Ethereum implements an execution environment on the blockchain called the EVM. Every node participating in the network runs the EVM as part of the block verification protocol. They go through the transactions listed in the block, they are verifying and run the code as triggered by the transaction within the EVM, as we can see in this figure. Now let's have a look at an Ethereum gas. Now let's see what is gas and why do we need it. When a contract is executed as a result of being triggered by a message or transaction, every instruction is executed on every node of the network. This has a cost. For every executed operation, there is a specified cost expressed in a number of gas units. Gas is the name for the execution fee that senders of transactions need to pay for every aspect made on the Ethereum blockchain. Gas is purchased using Ether, which is the name of the cryptocurrency in the Ethereum blockchain. The price of gas is actually decided by miners, who can refuse to process a transaction with a lower gas price than their minimum limit. So it's up to the miners. They can decide the price of the gas. And if the total amount of gas used by the computational steps spawned by the transaction is less than or equal to the gas limit, then the transaction is processed, and if the gas exceeds, then all the changes are reverted, except that the transaction is still valid and the fee can still be collected by the miners. So now let's have a look at few terminologies related to gas. First of all, let's see what is gas used. It's actually the total gas consumed by the transaction. Gas price. It is the price in ether of 1 unit of gas specified in the transaction. And the total gas can be calculated using gas used into gas price. And now let's see what is gas limit. It refers to the amount of gas that we are willing to spend on a particular transaction. Now let's see what is solidity. So solidity is the language in which we write our smart contracts in an Ethereum blockchain. It is a high-level language for implementing smart contracts. It was influenced by C++, Python and JavaScript, and it is statically typed, supports inheritance, libraries and complex user-defined types among other types. So now let's dive into the code. So we will be developing our smart contract on Remix IDE. It's an online compiler for Solidity. So Remix is an integrated development environment or IDE for smart contract development. It focuses on the development and deployment of Solidity written smart contracts. And Remix is a good solution if we intend to do the following things. If we want to develop a smart contract or debug a smart contract's execution, access the state and properties of already deployed smart contracts, debug already committed transactions, or if we want to analyze the Solidity code to reduce coding mistakes and enforce the best practices. So as you can see, this here is the Remix compiler, Remix IDE. And here we have different environments from which we can choose, like the Java VM, injected Web3 or web provider. But for this, we will be using the JavaScript VM. And with that, we get few accounts. As you can see, these all are the accounts that we get with this JavaScript virtual machine. And here, as you can see, with each account, we have some ether associated with it, like 100 ethers. This is actually not a real ether. It's a fake ether that we get if we want to test our Solidity script in a test environment. And this here is the gas limit, which I talked about earlier. So now let's have a look at the code. So first of all, we define the compiler version using the pragma Solidity. So this here, I'm defining here the compiler version, that is 0.4.18. Then I define the contract naming election. So I can think of contract as defining a class in any other programming language. I define contract as election. Then after that, I define a string of array name as candidates for storing list of all the candidates participating in an election. And mapping in Solidity is used to form a key value pair. So here the key will be of type string and the value returned by that key will be of integer. uint8 means integer of 8-bit long. And its name will be number of votes. After that, we will define a function, and this function is actually a constructor, and it's taking candidate name as its parameter, and it is public so that everyone can use it. And we will just push the candidate in the already array of candidates. Then again, we have defined a function for adding up the candidates in the candidate string, array of string. Then for voting, if you want to vote for any particular candidate, then this function is for that. I iterate, it's a loop. I will start with the loop, tell all the candidates present in that array. And since there is no technique to compare two strings present, therefore we use keycac 256. This actually compares the hash of both the values. So I compare the hash of candidate name and the candidate that is present in an array, and if both the hash values are same, then I increment the number of votes for that candidate. And for displaying the number of votes, what I do is I do the similar task. If the number of candidates are same, then just return the number of votes for that candidate. And for running this contract, I just to provide a value to the constructor, I will just write the name Dhruv and I will type create. And once I do that, here as you can see, I get this. So this here is my contract. I can add any candidate name. So I need to write that in a double quotes. First of all, suppose Aman, add candidate. And if I want to vote for any candidate, I just need to write the name for that candidate. Suppose Dhruv. And if I want to see how many votes been received by Dhruv, I just need to type. And it's gonna show 1. So Dhruv has received 1 vote. And let's see for Aman now. And Aman has received 0 votes. So these are the details we can see. It's the log values and all the details. The decoded input, that is Dhruv. We can see all the details over here. So yes, that's it for today, guys. And if you like my videos, don't forget to like, subscribe and share. Thank you.